Bienvenidos, Ushamdi, and welcome, CTS230, Section 841 students, for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or Scaling Networks V6 course from the Cisco Networking Academy, and this evening's video tutorial and solution set is going to be on Packet Tracer Activity 6.4.3.4, where we take our first look at configuring Eigrp for IPv6. So let's go ahead and dive in. And the good news is, as you take a look at the topology here, very similar to the last topology, in fact, completely identical with the exception of IPv6 addressing as opposed to IPv4 addressing. And so in IPv6, we say prefix and prefix length because there really is no concept of a subnet mask, so to speak, right? So it's a prefix and the prefix length. And so let's dive into the activity here. And it's pretty straightforward, just like our other activity. It's going to give us a nice introduction into configuring Eigrp for IPv6. Now, we're going to enable IPv6 routing on each of the routers. Let's start with router 1. And this is important because if you don't do this, you can't configure the routing protocol. And so let's see what happens if I go from user exec to privilege exec with the enable command, and then into global config with configure terminal. If I say IPv6 router Eigrp1 and hit enter, I end up with this error message here, right? It tells me that IPv6 routing is not enabled on the router. And so by default, IPv6 routing is not activated. We need to go ahead and say IPv6 unicast routing. And then that command, that IPv6 router Eigrp1 command, that command will then work. Now, one of the significant differences here, you'll notice I've used AS1, I've enabled the Eigrp for IPv6, but nowhere over here is there a network command. In fact, if I do a question mark, do you see the option for network? Right? And the answer is no. If I come back over here to a real Cisco router, we're on router 4 still, I'll go into privilege exec, and we'll say, let's get into global config, where I'm going to say IPv6 unicast routing first, and then we'll say IPv6 router Eigrp1, and I'll do a question mark here. We're going to have a lot more options, not significantly more, but enough to see the difference between Packet Tracer and a real Cisco router. And you'll notice that there is no network command. Now, this is interesting because what happens then? How do I turn Eigrp, right? How do I activate the Eigrp process on an interface? Well, what if I say do show IPv6 Eigrp interfaces? Yeah, we get this Eigrp1 is shut down. Now, this is interesting, right? Because if I come back over here to our real Cisco router and say do show IPv6 Eigrp interfaces, right? It just simply doesn't list any of the interfaces out. Now, it doesn't say that it's shut down. And this whole concept that the Eigrp process is shut down by default, right? If I was to say do show run, and there's not much configured on here, so we'll walk through down to the Eigrp setup, you'll notice it doesn't say that it's shut down. As I work my way all the way through, if I were to say do show run and include shutdown, well, that's for my interfaces, probably not the best choice. But again, the point being is that with the 15 code and later, Eigrp is not shut down by default. And this used to be a trap that learners would fall into, is they would forget to say no IPv6 Eigrp shutdown. In fact, if I say do show run and we come down here, you can see it says it's shut down. And we don't have that. And actually just no shut is going to bring it up. We don't have that under the real Cisco iOS. So definitely be aware of this. If I say do show IP, or how about do show version? So we're kind of running 15.1, right? A simulated version of 15.1.4 M4. And at this point, 15.7 is out, so this is kind of considered a little old, right? Probably shouldn't be running 15.1 in production, but again, do show IPv6 protocols. Let's see what protocols we have configured. We've got Eigrp for IPv6, but it doesn't show me that it's shut down in here anywhere, right? It shows us our metric, our composite metric values for K1 through 5. We get that hop count, the variance, and then that's it, right? We don't see much. Eigrp is not running on any interfaces. So in order to enable Eigrp for IPv6 on an interface, we're simply going to go to that interface with that has the IPv6 address on it, or we're going to we're going to go to the interface that has the IPv6 address on it, and we're going to enter the command IPv6 Eigrp with our autonomous system number. So let's go ahead and do that. Do show IPv6 interface brief, and we can see that we're going to be looking at gig 00 and then the same serial interfaces. So let's make that happen. So interface gigabit Ethernet 00, and I would say IPv6 Eigrp with the AS number that I've chosen. And that's it. And that will enable the Eigrp for IPv6 process on an interface. So again, there is no concept of network, a network command under the global configuration section. And I also skipped by something here. Yeah, it says it's shut down by default, but that is not true for later releases of 15 and beyond 15.1. I don't believe it's shut down by default. And we had to do some router ID work. So let's actually take a step back here. Let me go into IPv6 router Eigrp1, and we'll say Eigrp router ID is going to be 1.1.1.1. Now, something to think about, right? Remember, the router ID, that is not an IP address. So if I was to say do ping 1.1.1.1, and we talked about this in class, am I going to get a response back? And the answer is no, because again, that is not an IP address. It is a 32-bit value in dotted decimal notation that could mirror an IP address that you have configured on the router, or that you have configured with the Eigrp router ID statement. It looks like an IP, but I've just shown you that is not a viable IP address that we can use for reachability and connectivity. It is nothing more than a 32-bit dotted decimal value that looks exactly like an IP address. But it is not an IP address, it is a router ID. So we set the router ID. Let's go into interface serial 000, IPv6, Eigrp1, and then interface serial 001, and we'll run that same command. Now, let me go back, because they should be asking for the passive command. I'm looking to see if they're asking for this. Shut down. Router ID, right. So we need the router ID or else the process will not start. Eigrp for IPv6 configured on the router interfaces. Are they asking us to do passive here? And I don't see that yet. All right, so we'll move forward, assuming they don't want us to do the passive interface. Well, let's check. Let's say IPv6 router Eigrp1, and I'll say passive interface gig 00. And let's see if we go from 28 points to any additional points. And we do not. All right, so no passive interface gig 00. So we're going to stick with this for right now without passiving any of the interfaces. So let's walk through that again. And again, it's a pretty straightforward process, and the commands that we'll use to do the verification are very similar. And typically you'll notice the only difference is the addition of IPv6 in our command syntax. So we go from user exec with the greater than prompt. We use enable to get to privilege exec into global config, IPv6 router Eigrp, Eigrp1, And IPv6 routing is not enabled. IPv6 unicast routing, and then we'll rerun router IPv6 router EIGRP1. No passive interface required. We'll set our router ID, or I mean the EIGRP router ID to 2.2.2.2. No network commands, right? We've got to get under these interfaces here. And here it looks like we are only, oh, whoops, do show IPv6. Sorry, IPv6 interface brief. I looked at that and I was like, that does not look right. So interface gig 00, IPv6, EIGRP1, interface serial 000, IPv6, EIGRP1, interface serial 001, IPv6, EIGRP1. And so we've got that all set up. So what did you notice? Do show IPv6 interface or IPv6 EIGRP interfaces. So EIGRP is still shut down, right? And that's the comment that they made. But again, on more recent versions of the code and pretty much anything past 15.1, I'm very confident in saying that it's not going to be shut down by default. So here's what we want to do. Let's say, I keep saying router EIGRP. So IPv6 router EIGRP1, and I'm going to say no shut, right? Now let's say do show IPv6 EIGRP interfaces. Again, show IP EIGRP interfaces, show IPv6 EIGRP interfaces. So those are the interfaces where EIGRP is running. Let's do the same here so we can at least get a no shut, at least get an adjacency set up here. And there we go. So it's up. We've got a new adjacency. So now I can say do show IPv6 EIGRP neighbors, right? So again, show IP EIGRP neighbors, show IPv6 EIGRP neighbors. Now, very important, and this kind of goes back to IPv6 101, and it's when you look at the link local address here. So the question is, over which type of IPv6 is the neighbor adjacency formed? Exactly. It's formed using the link local address, not a global unicast address, right? And this is important because when you talk about interfaces, remember, what is the only IPv6 address that is mandatory on an interface? Right? If you're going to use that interface with IPv6, what type of IPv6 address do you have to have on the interface? Exactly, the link local address. So I can have an interface with only a link local address. I don't have to have a global unicast address on there that accompanies or that is in addition to the link local address. So in fact, when we say do show IPv6 interface brief, what do we see? We see that we have both global unicast, right, and link locals, and that's fine. But unless I'm using these global unicast addresses for something else, I don't need to have them there. I would only need the link local address to establish this adjacency. All right, so the adjacency is up. We've taken a look at that. Let's jump on to router 3, right? So nice, easy introduction here into EIGRP for IPv6. And again, we go from user exec with the enable command to privilege exec with the conf t into global config, IPv6, and let's get the unicast routing taken care of first. IPv6 router EIGRP1, and we're going to put the router ID in here right away, EIGRP router ID, and this is 3.3.3.3. No passive interface command required, so do show IPv6 interface brief. And again, it's interface gig 00, IPv6 router IPv6 EIGRP1, interface serial 000, IPv6 EIGRP1, interface serial 001, IPv6 EIGRP1, and that gives us everything we need on all those interfaces with the exception of what? What do we not do? So, and I keep transition from 4 to 6 is difficult here. So IPv6 router EIGRP1, no shutdown. And that's going to bring the EIGRP process up, and you can see we get our adjacencies established with the two neighbors, and that pushes us out to 100 out of 100. And taking a quick look here, do show IPv6 EIGRP interfaces, right? So we see the same thing. You can see that there's no peers established out the gig 00. And let's go ahead and do a debug, right? Let's say debug EIGRP packets. I think that's all we can debug. And what do we see? Right? We see the packets, and now we see the IPv6 multicast address. And let me kill this here. We have what we need. We see the IPv6 multicast address for EIGRP, which is FF02::A. So it doesn't use 224.0.0.10, right? It uses FF02::A, and A in hexadecimal is equivalent to the decimal value of 10, right? So it kind of keeps it simple for you. But you'll notice, right, what's going on here? It didn't have us passive those interfaces. And yes, again, chances are you're going to passive the interface out which there are no EIGRP speaking neighbors. So it would be the gig 00 interfaces on all of these routers because we don't have any EIGRP speakers out here. So there's no need for me to be sending the IPv6 multicast packets at FF02::A out there. And then here you go, the receive of the send and receive of the hellos using the link local address. Nowhere in here do you see the global unicast address in terms of the hello packets that are being exchanged. Let's take a look at the show IPv6 route EIGRP, and I apologize, show IPv6 route, right? And here is the routing information. It doesn't look like it likes that command. In fact, let me check. That should be a legitimate command. Show IPv6 route EIGRP. Yeah, that is a good command. It's just the packet tracer doesn't like it. I was making sure I didn't have arguments mixed up there. So again, you can see D for the diffusing update algorithm for dual. That is how you identify EIGRP routes in your routing table. And so when we look at EIGRP for IPv6, what are the differences? Well, number one, we have to enable IPv6 unicast routing, first and foremost. Number two, we have to go ahead and enter the IPv6 EIGRP autonomous system number command under the interfaces on which we wish to run EIGRP for IPv6, right? Very, very important. Other than that, when we look at the verification and validation commands, when we look at the show IPv6 protocols, right? Show IPv6 EIGRP neighbors. Show IPv6 EIGRP interfaces, right? The commands are identical to the commands for EIGRP for IPv4. It's just simply changing the option in the command from IP to IPv6. And again, other than that, it's pretty much the same, right? The metric is calculated. The composite metric values, the K values are the same, right? K1 through 5. And you can see bandwidth K1 and delay K3 respectively. Those are on. K2 load, 4 and 5 reliability. Those are off. And the metric is calculated the same way. So from R3's perspective, show IPv6 route, we should see, what was it, 2 million something something, yeah, right here. To get over to the LAN segment behind router 1 and look at via the next hop. So the successor, and you know what, I didn't even show the topology table. Let's pull that up. Show IPv6 EIGRP topo. One of the most important commands. Let's make sure we take a look at this, right? And it's from here that we launch that conversation about feasible distance, feasible successor, reported distance, right? How do we check the feasibility condition. So the topology table, same command, right? Except for IPv4, we would just say show IP EIGRP topology. And what do we see here? So it's in the passive state. This is what we want. If you see A, it means the route has gone active. And this is bad, right? Because it means that EIGRP and the diffusing update algorithm and the finite state machine are trying to find, right, are trying to converge and make a decision as to whether or not this is reachable, and if so, through whom. So via FE80::1, that is the successor. 2 C's and 2 S's. That is my successor. This is my feasible distance, right? That is the cost, the EIGRP composite metric. Now, we reach that point where I have to lie to you. This is going to be shown in Chapter 6 as the feasible distance. And for this course and the CCNA test, or the ICND 1 and 2, it's the feasible distance. I'm going to do a supplemental video where I'm going to tell you the ugly truth, right? For now, that is the feasible distance. This is the reported distance. So in other words, this is the cost that the successor router 1 is telling router 3, that's my reported distance, right? So we've got to add the cost of our outgoing interface. And how could we check that cost right there? All I would need to do is do a show interface gig 00 on router 1 and get the delay and the bandwidth settings and then work it out in that equation. And then I would come up with 2816, right? And there is the outgoing interface that I am going to be exiting. And so it's here in this EIGRP topology table where we keep the successors and feasible successors handy. And take a look here. What happens when we have equal to equal cost paths? So here's the feasible distance. We can see that the metric here is the same. So we would load balance across the path to router 2 and router 1 in order to reach that network segment right there. So we have 2 equal cost paths. This is the equal cost multipathing, right? And so you can have multiple successors. So let's say that this was, 956. This could be a feasible successor, right? Or actually, yeah, if that was 956, and we'll say this is strictly less than, the reported distance is strictly less than the current, oh wait, so 216, sorry. Oh, is it already 123, 123? I may be making this more complicated. Yeah, 2621. So I take that back. Let me see if I can pull those out of there. Nice. Yeah, so this could be the feasible successor, but since it's equal cost, right, they're both successors, and I will use both of these to send traffic. In other words, these are both equally good, right? They're both equally good. If this was 29, right, which means it's not equally good, it could still be a feasible successor as long as the reported distance, and this is the feasibility condition, very important, and the feasibility condition, which is the condition that needs to be met in order for a candidate successor of some kind to be considered a feasible successor. The feasibility condition states that the reported distance of the possible next hop router must be less than the current feasible distance of the current successor. And when we look at these two numbers, is that true? Yes. So you say this would meet the feasibility condition if, and again, we're assuming here that the cost is higher, right? The overall cost is higher, so it's not a equal cost multipathing situation, but it meets the feasibility condition because the reported distance is less than the current successor's feasible distance. Therefore, it would show up in the topology table as a feasible successor. And when we said show IPv6 EIGRP topo, we would see the feasible successor. What if that was a 9 right there, and the feasibility condition is not met? When I say show IP EIGRP topo, would that show up here? And the answer is no, it wouldn't. And here's why. You would have to use the all links option. All right, and that is going to wrap up this packet tracer activity 6.4.3.4 on EIGRP for IPv6. Thanks so much for watching, and I will see you guys Tuesday night.